Hello class 9. Today in this video we're going to see a new exercise, that is exercise 6.2. Let's recall what you have learned in the lower classes. Now in the lower classes you have learned that if a line intersects any two lines at two distinct points, then that line is called transversal. Here this line is intersecting these two lines here at two distinct points, here and here. Now so let's say this is L and this is M, and this is another line here, let's call it N. Now this N is intersecting these two other lines at two distinct points, so such lines is called transversal. Now here we have 8 angles formed here. Let's say this is 1 2 3 4 5 6 7 8. Now let's see what are corresponding angles, pair of corresponding angles. Now this angle 1 and angle 5, they are called corresponding angles. So these two angles are said to form a pair of corresponding angles. Similarly, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. Okay, now look at this angle 1 and angle 5. This angle 1 and angle 5. Now they are called corresponding angles. Now let us see why they are called corresponding angles. Angle 1 lies to the left of this transversal, left side, and this angle 5 also lies to the left of this transversal, and also this one is above this line L, and angle 5 is also above this line L. So that means they are in the similar conditions. So such pairs of angles are known as pair of corresponding angles. Also let's see this angle 2 and angle 6. Now this angle 2 is to the right of this transversal, and angle 6 also right side of this transversal, and 2 is on top of this line, and 7 also above this line. So now they are also called pair of corresponding angles. Now 3 and 7, 3 is to the right of this transversal, 7 to the right, and 3 is below this line here, and 7 is also below this line. So they are also in the similar conditions. Now this 4 and 8 similarly are in the similar conditions. Left side, below this line, below this line. So we have 4 pairs of corresponding angles here. Let's write down here. Pairs of corresponding angles. Pairs of corresponding angles. Okay, the first one is angle 1 and angle 5, and then angle 2 and angle 6, angle 2 and angle 6, and then angle 3 and angle 7, angle 3 and angle 7, and then we have angle 4 and angle 8, angle 4 and angle 8. Now let's see the next types of pairs of angle. This pairs of interior alternate angles. Pairs of interior alternate angles. Now this angle 3, 4, 5, 6, they are known as interior angles because they lie between these two lines. And angle 1, angle 2, angle 7, angle 8, they are known as exterior angles because they lie outside these two lines. So now when we say pairs of interior alternate angles, now alternate angles, this angle 3 and this angle 5. Now look at these two angles, angle 3 and angle 5. Now 3 is to the right of this transversal, 5 is to the left of this transversal, and this 3 is below this line and 5 is above this line. So these 3 and 5 are totally opposite. Everything is opposite. So such type of pair of angles is said to be pairs of alternate angles. So alternate angles. So pairs of interior alternate angles, angle 3 and angle 5. And also this angle 4 and angle 6. This angle 4 and angle 6. Because 4 here lies to the left and 6 here lies to the right, and 4 is below this line and 6 is above this line. So angle 4 and angle 6. So we have two pairs of interior alternate angles. Now exterior alternate angles are angle 1 and angle 7, angle 2 and angle 8. Now let's see axiom. Here it says, if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. Let's draw two parallel lines here. Now this line, these two lines are parallel lines. Now what it says here is, if a transversal, now this is a transversal, if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. Let's say this is 1, 2, 3, 4, 5, 6, 7, 8. Now the corresponding pairs of corresponding angles are 1 and 5, 2 and 6, 4 and 8, 3 and 7. Now all these pairs of corresponding angles are equal only when these two lines are parallel. So here it says angle 1 is equal to angle 5. The corresponding angles are equal. Angle 2 is equal to angle 6. Angle 2 is equal to angle 6. Angle 3 is equal to angle 7. Angle 3 is equal to angle 7. Angle 4 is equal to angle 8. Angle 4 is equal to angle 8. Now these pairs of corresponding angles are equal only when these two lines are parallel. If they are not parallel, if they are like this, then the pairs of corresponding angles will not be equal. So that is one very important point, one very important axiom. And now we will see the next axiom. That is axiom number 6.4. If a transversal intersect two lines, if a transversal intersect two lines in such a way that one of the pairs of corresponding angles is equal, for let's say for example this is 120 degree and this is also 120 degree. Now these two angles are pair of corresponding angles. Now since these two corresponding pair of since these two angles are equal, these two lines will be parallel. This line, let's say L, and this is M. L will be parallel to M. Next we have a theorem here. The theorem 6.2. Here the theorem says, if a transversal intersect two parallel lines, here also we are talking about parallel lines. This is the transversal. Now if a transversal intersect two parallel lines, then each pair of alternate angles is equal. So we have two pairs of interior alternate angles, this one and this one. Now these two angles will be equal if these two lines are parallel, and this angle and this angle will be equal. So the pairs of alternate angles are equal when the lines here are parallel. Now to prove this, it's very simple. Let's say this is 1, 2, 3, 4, 5, 6, 7, 8. Now we know that vertically opposite angles are equal, so angle 1 will be equal to angle 3. Now angle 1 is equal to angle 3 because they are vertically opposite angle. Vertically opposite angle. Vertically opposite angles. Let's call this 1. Again, angle 1 and angle 5 are equal. Angle 1 and angle 5 are equal. Angle 1 and angle 5, they are pair of corresponding angles. Since corresponding angles, they are a pair of corresponding angles. Corresponding angles. Let's call this equation 2. Now from this 1 and 2, angle 1 is equal to angle 3. Angle 1 is again equal to angle 5, which means angle 3 is equal to angle 5. From 1 and 2, we get angle 3 is equal to angle 5. Now angle 3 is this angle, angle 5 is this angle. These two are alternate angles. So this is how we can prove this. So similarly, you can show that angle 4 and angle 6 are equal. Now let's see the next theorem. Theorem 6.3. Now theorem 6.3 says if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. That is just the reverse of this, converse of this theorem 6.2. Here it says if a transversal intersects two lines. If a transversal intersects two lines in such a way that one of the pair of interior alternate angles are equal, then the two lines are parallel. For example, let's say this is 60 degree and this one is also 60 degree. Now these two are alternate angles. So now since the alternate angles are equal, these two lines will be parallel. This one and this one will be parallel. Let's say this is L, this is M. L will be parallel to M. The reason is the alternate angles are equal. Now let's see the next theorem given here. Next theorem we have if a transversal intersect two parallel lines, then each pair of interior angles on the same side of a transversal is supplementary. Now this is also a very important theorem which you will be using very oftenly while doing exercise. So here it says if a transversal intersect two parallel lines, these are two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary, which means this is on the left side, this is also on the left side, and these two angles are interior. This is on the left side of this transversal, this is also on the left side of this transversal. Now these two angles are supplementary, which means if the sum of these two angles is 180 degree, the sum of this angle and this angle is 180 degree. So they are also known as co-interior angles. Co-interior angles. And the sum of these two angles is 180 degree. Now next is 6.5. Theorem 6.5. Now here it says if a transversal intersect two lines such that a pair of interior angles on the same side of a transversal is supplementary, then the two lines are parallel. This is the converse of this, the opposite of this theorem. So here it says if a transversal intersect two lines, here the statement does not say these two lines are parallel. Here it says if a transversal intersect two lines such that a pair of the interior angles on the same side is supplementary, then the two lines are parallel to each other. Here let's suppose that this is 60 degree and this is 120 degree. Now if you add these two angles, we will get 180 degree. If we add these two angles, here we will get 180 degree. Now in such a case, these two lines are parallel. These two lines will be parallel only when the sum of the interior angles formed here is 180 degree. That is when these two angles are supplementary. Now we have one more theorem here. That is theorem 6.6. Theorem 6.6. And this theorem says lines which are parallel to the same line are parallel to each other. This is a very simple theorem. Let's suppose that this line is parallel to this. L is parallel to M. L is parallel to M. And let's take another line here. Again, this line, let's call it P. And let's suppose that L is also parallel to P. Now this line L is parallel to M, and again this line is parallel to this line P. What the theorem says here is these two lines will be also parallel to each other. This line and this line are parallel to each other because here L is parallel to M. Again, L is parallel to P. M and B are parallel to the same line L. So that is why these two lines are also parallel to each other. Okay, now we will go to exercise 6.2. Those are the important points. Those are the important properties that you have to keep in mind while doing this exercise. Let's see the first question here. In the figure, find the values of x and y and then show that AB is parallel to CD. Okay, solution. Let's see the figure here. This is 50 degree, this is x, y is here, and again this is 130 degree. Here this angle and this angle forms a linear pair. You have to recall what you have learned in the previous exercise. While doing the previous exercise, if there is a line here and another ray here, then since this is a straight line, the sum of these two angles is 180 degree, and these two angles are called linear pair. These two angles are called linear pair. Now so here this angle and this angle forms a linear pair, so the sum of these two angles will be 180 degree. So here we can say x plus 50 degree, this will be equal to 180 degree because these two angles forms a linear pair. So now x is equal to 180 degree minus 50 degree, and this implies that x is equal to 180 minus 50 is 130. So the value of x is 130 degree. Now again here these two angles, this angle and this angle, they are vertically opposite angles. So since vertically opposite angles are equal, y will be equal to 130 degree. So again we can say here y is equal to 130 degree. The reason is since vertically opposite angle, since they are vertically opposite angles. Now here x is 130, y is also 130, so x and y are equal, therefore x is equal to y. Now x is this angle and y is this angle. Now here these two are alternate angles. Now since the alternate angles are equal, these two lines must be parallel. So this implies that AB is parallel to CD. So here, alternate angles being equal. So since the alternate angles are equal, these two lines are parallel. This is what we have to show here. So this is the solution for this first question. Now let's move on to the next question. Now let's see question number 2. Here in this figure, AB is parallel to CD and CD parallel to EF. AB parallel to CD. This and this are parallel. And CD is parallel to EF. Again, this is parallel to this one, EF line. And Y is to Z is equal to 3:7. So the ratio of Y and Z is given here. So that is 3:7. And we have to find the value of X. X is what? AB is parallel to CD. And also CD is parallel to EF. This is given. And CD also parallel to EF. This is also given. Now since AB is parallel to CD and CD is parallel to EF, this AB must be also parallel to EF. Therefore AB is parallel to EF. Since lines which are parallel to the same line, are parallel to the same line are parallel to each other, I've already explained this. If we have a line here which is parallel to this line, now this line and this line are parallel. Again, this line is parallel to this line. Now since this line and this line are parallel to this same line, therefore these two must be also parallel to each other. So that is the property that we have already discussed. So now since AB is parallel to EF, here, this AB and EF here, since they are parallel, now the alternate angles will be equal. So this is angle X and this is angle Z. So these two angles must be equal. They are alternate angles. So therefore X is equal to Z. Is in a sense alternate angles. They are alternate pair of angles. Now let's use what is given in the question. In the question it is given that the ratio of Y and Z, Y is to Z is equal to 3:7. Y is to Z is equal to 3:7. Y is to Z is equal to 3:7. This is given. So what we're going to do is, now this Y is to Z is this Y is to Z, you can write Y by Z, and this is 3:7 is 3/7. Now if you cross multiply this, and Y will be equal to Z into 3 is 3Z/7. Now here X is equal to Z, so instead of Z you can replace it with, Now this z you can replace it with x, so you have here 3x by 7. Now this x and y, these are angles on the same side of this transversal. So these are interior angles on the same side of this transversal. So since these two lines are parallel, the sum of these two angles is 180 degree. That is, they are co-interior angles. If a transversal got two parallel lines, then the interior angle on the same sides is supplementary. That is, if we take these two angles, then these two angles are interior angles, which is on the left hand side of this transversal. So these two angles is supplementary, which means if you add these two angles, you will get 180 degree. Okay, that is what we have already discussed. So here in our figure, this x and y are angles, interior angles on the same side of this transversal. So the sum of these two angles will be 180 degree. These two angles are also known as co-interior angles. Now we will say that x plus y is equal to 180 degree, because these two are co-interior angles. Now this one x plus, in place of y we can substitute this 3x by 7. So in place of this y, I'm going to write 3x by 7. So this is equal to 180 degree. Now let's take LCM here. LCM is 7. So 7 divided by 1 is 7. 7 into x is 7x. Plus 7 divided by 7 is 1. 1 into 3x is 3x. This is equal to 180 degree. Now you add this, you will get here 10x by 7 is equal to 180 degree. Now if we cross multiply this, we will get 10x is equal to 7 into 180 degree. Now dividing both sides by 10, we get here 7 into 180 degree by 10. Now this you can cut. So what we get now here is 7 into 18. So 7 into 18. So 7 8 are 56, 5 and 10, 7 1 is 7, so this is 126. So this is 126 degrees. So that is the answer.